This is printed at standard speed for generic PLA. But how much strength do we lose if we print the same parts at extreme speed? Welcome to this collaboration between MyTechFun and Roetz 4.0. We had this conversation with Jan. If you're not familiar, he's the guy who can print these benches in less than 2 minutes on his super fast DIY printer. And we became curious, how much weaker is the object if it is printed on this super fast speed? Or maybe using some good settings, the difference is negligible compared to some standard generic PLA settings in the Bambu Studio. So I prepared some test objects and we will use the same settings for the geometry, of course, speed, acceleration, temperatures will be different. And they will be printed in the same groups because his printer has this limitation, diameter I think 60 millimeters. And also we will use the same filament, not only same filament type, but it's exactly the same filament because he sent me together with these test objects, the filament he used for the printing. And actually he will create a video about this printing on his channel and we will publish this in the same time, so you can check his channel for this video. Now the most important is this test object for the layer adhesion test, printed with 2 walls and 20% infill. And here he decided to have the variable, and that's the layer printing time. The slowest is I think 8 seconds, and actually this is the setting for the generic PLA in the Bambu Studio. And the fastest is I think 1 second, or maybe there is something like 0 without any limitation, so they are printed on really high speed. This video is sponsored by Polymaker, but looks like partly sponsored by Jan because we use his filament and he still didn't accept my refund for the shipping fees. Let's take a closer look of the objects I got. For example, this is the bench chip printed in 1 minute and 59 seconds. Of course not the perfect bench chip, but less than 2 minutes. Okay, so these are test objects for the tensile test. This is a solid inside. For the layer adhesion, also solid inside. Grip test, this is hook. Impact test, they're relatively shorter because they have to fit on that 60mm diameter build plate. And this is for that elimination hook test. And then we have this for the layer adhesion printed with 2 walls and 20% infill. We can see the numbers. These are the seconds for the layer printing time: 8, 5, 4, 2, 1 and 0 without any limitation. I will measure their weight when I print my objects. My test objects will be printed on X1 carbon by group because I have no space and I don't have to restart the printing, and the fastest will be a little bit above 8 seconds for the layer, and sometimes it goes up to 40 seconds for the layer. We will use the same drying settings, 60 degrees Celsius, 6 hours. Usually I don't dare to dry the PLA on 60 degrees Celsius, except in this Famous because it rotates the spool during the drying. And I check it is fine, so it is not deformed or something like that. And here you can see a few seconds of the printing. These are for the tensile test. And side by side next to the Jan's DIY printer, so you can visually see the difference between the printing. These are for that vertical layer adhesion test, and again side by side the same test objects, 3 at once. These are different hooks and creep test, and from the Jan I got only this 1000 FPS slow motion video. My objects are labeled with letter M just in case, MyTechFun, and I want to measure their weight to see if there is any sign of the under extrusion, and I will measure them in these smaller groups. Okay, I think it is better to speed up this part, and sorry about the bad focus, but let's check the numbers. From these numbers we can see that my objects are heavier by approximately 4%. The difference is not big, but we will see how does it affect the strength. These are the objects for the layer adhesion, 2 walls and 20% infill, and this one was experimented with parameters, but the rest we can see more or less constant values. Only here we can see some signs of the under extrusion. We will see how does it affect the layer adhesion. Even without numbers, I can see some signs of the micro under extrusion. For example, here I can see some micro gaps between the walls. But overall this is quite good. I mean, I can see some waves here compared to this one, but this test is not about the looks, but about the strength. So let's test them. Tensile test with horizontal printed objects, printed on standard speed, and printed on super high speed. This test is less sensitive from the settings, and I got very similar values. And if I calculate the stress from this, which is force divided by area, or mass multiplied G divided by area, I will get that the stress is 49 megapascals calculated, which is very close to the value given on our website, which is 50 megapascals. Layer adhesion with vertical printed objects. These are solid inside, 4 by 4 millimeters. And since I have 6, I separated them in 2 groups. And now fast printing, first 3. And the second 3. So from 6 data, this is the average for the standard speed, and this for the fast speed. And we can see the standard is stronger by approximately 26%. Now there is something what I found out later, that actually he used a lower temperature than I did, because 220 is the default for generic PLA. But he is able to melt even 200 cubic millimeters per second flow on 200 degrees Celsius if necessary, could be one of the reasons for this lower layer adhesion. But don't be confused, this is my rating for this size of the test object, and even this is fantastic layer adhesion. Hook test, side by side 2 speeds. In this test, the standard speed was stronger by approximately 38%, but here not directly the layer adhesion is important, but the adhesion between the walls, and you will see this better in my next test. The elimination hook test, which is more interesting if I have several objects, and the weakest always falls out. A little bit bad angle for the camera, but with my eyes I could clearly see how walls detach from each other, so in this case the wall adhesion is very important. I think this test is the most important. 10 by 10 millimeters is the smallest cross-section area, printed with 2 walls and 20% infill. And the numbers you see is the set layer printing time in the seconds. Jan told me that with the 8-second version he was experimenting with the settings, and I should exclude this one. Others are printed with the same parameters, of course except the layer printing time and related parameters. I still want to include that 8-second version too, but I will highlight that that was experimental printing. Standard speed fast printing, and already mentioned that this 8-second version was experimental printing playing with parameters. Now I'm not sure, only this one doesn't really fit into this picture, the 4-second version. Maybe he was still experimenting with the parameters, I'm not sure, but after this more or less constant values, and only here I could measure some weakness in the layer adhesion, probably because of some small under extrusion. I still want to check one more thing. What happens if I print the test objects on 210 degrees Celsius instead of the 220? This is the test. And I think these are very similar values. I mean, I have one a little bit lower data, but otherwise very close to each other. Impact test, and I already mentioned that these test objects are a little bit shorter. For example, this is the holder for the Sharpie test, and these test objects are too small for it. But for the IZOD we have this notch which is used to locate the position. This means it will be held correctly, and the hammer hits approximately 5 or 6 millimeters from the top. First test. And the very last measuring, and the last test. Picture for the documentation, result for the standard speed, and for the fast printing. Again, standard speed stronger compared to the fast printing by approximately 27%. But one more interesting data, the standard deviation is much smaller with standard printing compared to the fast printing. This means a more constant quality we have with the slower printing. Grip has a deformation under constant load, not so important for this material, but I have the test object, so let's measure it. 14.74 and printed fast 14.96. Not big difference, but a little bit more deformation on fast printing. And after 1 day, printed on standard speed 16.42. And the fast printing version 18.20. More creeping. Actually, in this case, the adhesion between the walls is important, and yes, more deformation on the fast printed version. Okay, now some kind of conclusions. Well, more or less what I expected. Actually, I wasn't sure about the difference, and I thought the difference will be much bigger. I mean, there is a huge difference in the speed and acceleration between these two printings. Now, I'm not sure if you noticed that how great is the layer adhesion of this filament, and I want to investigate this a little bit deeper. Is this filament so great? Or there is one important difference between our printings, besides the speeds of course. He used 0.5mm nozzle because he don't have 0.4, and on the Bambu Lab I use 0.4 because we don't have 0.5mm nozzle. And all geometry was set equally, 0.5mm layer width and 0.2mm layer height. But looks like when we are using smaller nozzle, that a line is more squished and maybe it press better two layers to each other. So is this resulting so big improvement in the layer adhesion? This is something what I want to investigate a little bit deeper, not only with PLA but with many other materials. I hope you will follow me to that video too. Anyway, I hope we learned something from this video. Thank you for watching this video until the end. Thanks to Jan for his cooperation, and to all you others, happy printing!